Exercise 9.2 Problem 2. Construct a triangle PQR in which the base PQ equal to 6 cm, angle R is 60 degrees and the altitude from R to PQ is 4 cm. Very simple. Let's make a rough diagram. Okay. So this is our base PQ which is of 6 cm, and you take another point R, join PR and QR, and the angle R or angle PRQ is 60 degrees. And another condition which they say is that the altitude of R from PQ is 4 cm. That is, the perpendicular line from R to PQ is 4 cm long. If you see, this is basically tangent chord theorem. You have to use the tangent chord theorem. You can draw a circle around this, right? Okay. So basically, so this angle, if you this is a tangent, right? So you'll have to draw a line PX which is at 60 degrees, and then you draw a perpendicular line and all this kind of things. So this angle, this is the, according to tangent chord theorem, the angle between the chord and the tangent at one end of the chord is the same as the angle subtended by the chord in the alternate segment. So this is a segment of the chord and this is the alternate segment of the chord. So basically this angle subtended is 60 degrees. So you can use here tangent chord theorem. The only difference is that they say the altitude is 4 cm. We'll have to figure out how to do this. So it's basically like the previous problem, application of tangent chord theorem. Okay. And we'll have to just see a way to introduce this for altitude of 4 cm. Okay. Great. Now let's start. So draw a line PQ which is of 6 cm long. Okay. Next, we'll have to draw a line PX which is at about 60 degrees. Okay, 60 degrees. Okay, that is angle QPX equal to 60 degrees. So you draw PX which is 60 degrees to PQ, or angle QPX is equal to 60 degrees. Next we'll have to draw PY which is perpendicular to PX. Okay, so you have drawn PY which is perpendicular to PX. Next, we'll have to find the midpoint of PQ. How will you find the midpoint? The length of PQ is 6 cm. Half of it is 3 cm. So you'll have to take a radius slightly more than that. So let's take the radius more than half. So more than 3 means it is 4. So from point P, draw an arc, one on the top, one on the bottom, with a radius of 4 cm. Similarly, with the same radius, but with center as Q, draw an arc above and below. These two sets of arcs will cut each other and join the point of intersection. You will get the perpendicular bisector of PQ. So the first arc, okay, so with Q, okay, and then the second arc. So with P as a center, you are drawing this arc and this arc of radius 4 cm. With Q as a center, you are drawing this arc and this arc, one above, one below. Then join these 2 points, the intersecting points of the arcs. So that is the perpendicular bisector of PQ. Now this line will cut the PY at one particular point, that is O. Right? So with O as a radius, center, and OP or OQ as the radius, which both are equal, draw a circle. Now as per tangent chord theorem, so this is the chord and this is the tangent. The angle is 60 degrees. So this chord will subtend 60 degrees on any point on the on the alternate segment. Okay, so which means if you draw here, if you take point C as R as here, so angle PRQ will be 60 degrees, or if you take R here, okay, PRQ will be 60 degrees, or if you take R here, PRQ will be 60 degrees, because as per tangent chord theorem, this angle is the same as the angle subtended by the chord in the alternate segment. Any point on this alternate segment, if you take and join that point to P and Q, you will get an angle of 60 degrees. But the problem is they want an height of altitude of the triangle PQR, right? Altitude of the triangle to be 4 cm. So what you'll have to do, we have named this point, the perpendicular bisector meets the PQ at a point M. So with M as a center and 4 cm as a radius, draw an arc. Okay, I forgot to name this the K. So the alternate segment is PKQ, right? Now with M as a center, draw an arc cutting the perpendicular bisector. Okay, and the radius of these radius of the arc is 4 centimeter. So with MS and center and radius of 4 centimeter, draw an arc cutting the perpendicular bisector. Now draw a line parallel to PQ from this point, intersecting point. Passing through this intersecting point, you will have to draw a line parallel to PQ. So let's draw that. So that is R and R dash. Now you join PR and QR, that is the triangle. So now PRQ subtends an angle of 60 degrees, and at the same time the height of it is, altitude is 4 centimeter. This is 4 centimeter, so this is 4 centimeter also. Or if you join PR complement, PR dash and RQ dash, it will be the same. You will have the same angle of 60 degrees and the height will be, or the altitude will be 4 centimeter. Okay. So it's the same like previous problem. Only thing is that this is the additional step. So with M as a center and radius of 4 centimeter, draw an arc cutting the perpendicular bisector. It cuts at a point H, and draw a line parallel to PQ passing through this H, and that will cut the circle at 2 points R and R complement or R dash. So you can, the triangle is PRQ or PR dash Q. As I said, no, you can join from here to here also. So let's say this, so if you join this and this, so let's say this is Z. PZQ will be same 60 degrees. Now the question arises, why are we not using this? We cannot use this because it does not fulfill the second condition. The second condition, so the altitude will be much smaller. Okay, if the altitude is 4 centimeter here, this probably will be 2 centimeter. We want to have a triangle which is 6 for having an altitude of 4 centimeter. So that is why we are using this step. Okay. Now let's go through the construction. Draw the line segment PQ. So first step was we drew the line PQ of 6 centimeter. At P, make an angle QPX 60 degrees. At P, make an angle QPX. Draw PY perpendicular to PX. What is the next step? We drew PY which is perpendicular to PX. Okay. Then draw a perpendicular bisector of PQ. Okay. Perpendicular bisector of PQ, and that will meet the PY at one particular point, and that is to be named as O. This is what is told in this step. Next step, with O as a center and OP as a radius. With O as a center and OP as a radius, draw this circle. Okay, draw this circle. Then the segment PKQ, you can name, you can add name a point K, and that is PKQ is a alternate segment, contains the vertical angle of 60 degrees. So any point on this segment, if you connect it to P and Q, will subtend an angle of 60 degrees. That is as per tangent chord theorem. But we want to also have an altitude of 4 centimeter. So on the perpendicular bisector MO, mark a point H such that MH equal to 4 centimeter. So with M as a center and radius of 4 centimeter, draw an arc cutting the perpendicular bisector and name it as H. Then draw RH or R dash parallel to PQ, meeting the circle at R and R dash. Draw a line parallel to the PQ, and that will intersect the circle at R and R dash. Now complete the triangle PQR. So PQR is the required triangle which subtends an angle of 60 degrees and at the same time has an altitude of 4 centimeter. Alternatively, PR-Q is also required. It is also the required triangle. Okay. I hope it's clear. If not, please go through one more time. It will become clear. Thanks for watching this video.